Thank you very much, everyone, for joining. Thank you for being on time and early. I hope you are having a great day today. My name is Nick Lusson, and I work with Jubaili Bros Solar based in Nairobi, Kenya. Today, we are going to show you the PV diesel hybrid solutions. And we're going to explain what it is and the concept and how it works. And we're going to show you our solution for the PV diesel hybrids. Let's begin. I'm going to start by telling you a bit about Jubaili Bros Solar. So Jubaili Bros was founded in 1977 as a diesel generator company. So that puts us in a very unique position for today's webinar because we have a ton of generator experience, and we are an assembler and reseller of Perkins engines and Leroy Summers alternators and more. So as you can see the timeline on the screen, we expanded from Lebanon into several other countries, into the UAE, Nigeria, Afghanistan, Kuwait, Ghana, Qatar, Uganda, South Africa, Pakistan, and Kenya. And in 2017, we founded the solar division of Jubaili Bros. That's Jubaili Bros Solar. So as I've mentioned, we have generator experience and expertise, and we have solar experience and expertise. And today we're talking about the hybrid between the two. Here you can see a map of our global logistics reach. Everywhere that you see a flag, we have customers or distributors or resellers. So we specialize in places where the grid is weak and in challenging environments to supply reliable power. So at Jubaili Bros Solar, we have 6 pillars of activities that we use to support our EPC customers, and you can see them on the screen there. So the first one is product supply. So we can supply high quality products. The second pillar is training. A lot like this one, we can do lots of different training on a wide variety of topics for diesel generators, for solar installations, for solar equipment, on a wide variety of topics. We have lots of training. We have at least one training per week. The third pillar is engineering support. So this means we can help you with your designs, especially your solar designs. We can verify your designs. We can make sure your BOQs are complete and correct, and nothing is missing, and nothing is duplicated, and everything is optimized. The fourth pillar is leads. So from time to time, we engage with our end users, and they need referrals for EPCs and for other stakeholders and role players. So we're happy to pass those leads on to our qualified customers. The fifth pillar is referral to finance. So this is, we don't do financing ourselves, and we know that, especially in the solar industry, very often the upfront cost is an obstacle. All the CapEx is an obstacle. And we have partners who are in the finance industry who are happy to finance your projects. So we are happy to make these introductions to help you get your projects across the finish line. And the sixth pillar is after-sales support. So this is commissioning support, troubleshooting support, and warranty support. As I said, our model is to supply and support the EPCs. Now, with Huawei, this is one of our top partnerships. We are a tier 1 partner of Huawei in East Africa, Southern Africa, West Africa, parts of the Middle East, Afghanistan, Pakistan, UAE, and more. And we are the VAP, which means we're a tier 1 partner who can handle inquiries up to 100 megawatts. And we're also CSP, which is Certified Service Provider. So this means we are trained and certified to handle your Huawei service-related issues. All right, now the reason we're here today is to discuss PV diesel hybrid solutions. So we're going to explain in detail what it is, what it looks like, the functions and the applications, and we'll show you the specific solution as well. So here it is. Basically, we're doing introduction, explanation, and we'll look at the product. So to begin, we need to discuss the concept of LCOE. LCOE is the levelized cost of energy, or the levelized cost of electricity. So this is a figure that will show you how much your electricity costs. And it's a very good indicator of if you are paying too much for your energy or if you're paying a good amount. And it's a good indicator if your investments in generation or power supply have been giving you a good performance and a good return on your investment. So the way that you calculate LCOE is shown there on the bottom right. It is your CapEx plus your OpEx divided by the amount of electricity that has been generated. So the CapEx is your capital expenditure. This is all of the money that you spend on day one to install or procure something. So this includes all the equipment costs, the land costs, the installation costs, the man hours, all of the money you spend to install something, plus the OpEx. OpEx is operating expenses. So how much money did it cost to keep this system running over time for the replacements, the repairs, maintenance, things like that. So when you add those two together, you get all the money that you've spent on your energy system. So then you divide it by how much energy you actually produced. And when you do this calculation, it will show you the LCOE, the levelized cost of your energy, and you will be able to know if you're paying too much or if you're getting a good return on your investment. So now let's talk about diesel generators for a moment, because diesel generators have been the solution of choice for decades in remote areas that are not served by the national grids, because you can see there the benefits. They are very reliable and it's a relatively low upfront cost. And you can put them almost anywhere. And logistically, it's possible to get them almost anywhere. So it's fast to put this power source in a new place. It's, as I've said, it's very reliable. There's usually not a lot of problems in the power supply if you size your generator correctly. So this is why generators are so common, because for decades they have provided a very reliable source of energy for remote areas and underserved areas and places where the grid is unreliable or it doesn't reach, and all of these things. Diesel generators have been a great solution for decades. But the challenges of diesel generators are there on the right. So number one is pollution, because they are polluting. They consume diesel energy, diesel fuel. So they put a lot of carbon and black carbon and soot and fine particulate matter into the atmosphere. The next is the high operating cost. And this is mostly the cost of diesel, because you have to have a constant supply of diesel to keep your diesel generator working. And this is a never ending cost and it's very expensive. But then there's also maintenance on your diesel engines. They have to have regular maintenance. In fact, you should have, ideally speaking, you should have more than one diesel generator, because one is running while the other is being maintained. And then you switch to the other and you can maintain the first. So you require a technician on site almost all the time. So the operating costs are quite high. And the third challenge is the logistics cost, because not only is the logistics of delivering the generator to site, but you have to have a constant supply of diesel. And if you're in a remote area, that can be a very big challenge. I've been in areas where the roads are seasonal, and when the rains come, those roads are not usable. So it's a big challenge. How do you get diesel supply when the roads are not passable by trucks? And so this is a common obstacle, the logistics costs of a constant diesel supply. And the cost of diesel is always going up. And so here I've put a graph of the diesel price in East Africa as a reference, but it's pretty much indicative of the global price of diesel. So you can see on the left is 1992, on the right is 2020. It's a pretty steady increase the whole time. There was a dip a few years ago where the price went down to zero, and we all know that was just an anomaly. Over time, the price of diesel will always go up. It's becoming more scarce. There's other sources of power that are surpassing diesel. So this is a big challenge of using a diesel generator. The price of diesel is continuing to go up. It's a never-ending cost for you. So where does a PV diesel hybrid make sense? So I've put 6 bullet points there where you may be able to tell if a solar diesel hybrid is right for you or your customer. The first one is remote areas underserved by the grid. So if you are in an area where the grid is unreliable, frequent blackouts, very poor power quality, all of those things, and you need reliable power, then a PV diesel hybrid makes sense. Number 2 is when the effective cost of diesel exceeds $0.8 per liter. And that's almost everywhere. So if you're consuming a lot of diesel, this is a good solution for you. Number 3 is where the sunlight is abundant. And again, that's most of the earth qualifies, except if you're in a very, very cloudy place or very high or low altitude latitudes. Number 4 is where diesel generators operate in daytime hours. So if you have any customers that use a diesel generator during the daytime, then this is a prime solution for them, and they will thank you for providing this solution. Number 5, where the logistics costs associated with diesel are high. As I mentioned, logistics costs are very difficult, and if someone is in a very remote area where the price of logistics really affects their bottom line, then adding solar to their diesel generator is a great option. And number 6, where storage and security of diesel is a concern. Because if you're in a remote area, you probably bring in large amounts of diesel and you have to store it. And diesel is often stolen, and it has to be stored safely. So if storage and security is a concern for your diesel, then you should consider adding solar. So this graph is just showing the cost of diesel over time and the cost of solar energy over time. So I'm sure we all know that the cost of solar energy over the last decade or the last 2 decades has dropped dramatically. It's just unbelievable how much cheaper solar is today than it was 10 years ago. And that's shown by the red line. The red line is declining. And the cost of diesel is doing the opposite. 20 years ago, the cost of diesel was much less than it is now. And it's continuing to increase. And we are at a point today on the graph where the cost of solar is actually much lower than the cost of diesel. The levelized cost of solar energy is much lower than the levelized cost of diesel energy. And over time, this gap will become bigger. So what you want to do is to increase your consumption of solar because it's cheap and decrease your consumption of diesel. You want to get your energy mix to consume more solar and less diesel, and you will save money. All right, so now let's explain how the hybrid solution works. So on the screen is a very simple line diagram of how it can work. And there's basically 6 components that have been labeled, and we can take a look at each one. Number 1 is the solar panels. Number 2 is the mounting structure for the solar panels. Number 3 is the DC cables. Number 4 is the grid inverter, the PV inverter. Number 5 is the fuel save controller. And number 6 is the genset system. So we've labeled them in this way because Jubaili Bros can supply all 6 of these. Jubilee Bros can supply all of these items. And on the right, it also shows what else we can do. We can do the design support, the logistics support, the commissioning support, the after-sales support, and the warranty support. Now, the key part of this system is number 5, is the fuel save controller. So that's what we're going to discuss in detail today, because the rest of it works just as normal. The solar panels, the inverter, all of those we discuss in other webinars, and you should be familiar with them. Also, the diesel generator, it's a standard diesel generator. You don't need special diesel generator. Number 5 is the piece of equipment that we are going to discuss today. Okay, so it's called a fuel save controller. And why does the PV plant need this PV diesel controller? It's because the PV plant must be controlled to ensure smooth system operation. So what does this mean? It's shown on the 3 puzzle pieces there. So the diesel controller, the fuel save controller, does these 3 main functions. Number 1, it controls the PV plant generation to maintain the maximum PV output. So we want to consume the maximum amount of solar energy as possible, because the solar energy is basically free. Once you have the equipment, once you have the panels, the sunlight is free. So we want to consume maximum amount of solar energy. Number 2 is to achieve a high proportion of PV without impairing the stability of the other power sources. So it takes an intelligent controller to maintain the stability between all of the sources of power. And number 3 is it monitors the flow of energy throughout the system, managing the PV system to ensure that the switching of heavy loads does not affect the system stability. So we know that in the day, a load will go up and down very quickly sometimes. So this intelligent controller makes sure that when your load varies, that everything is still stable. And even if the production varies, like if there's clouds, the PV controller balances all the sources of power with the load, and it protects the equipment. So basically there's 2 parts of this. There's the protection and the performance. So the protection is shown on the left. It protects the generator. The fuel save controller protects the generator from minimum loading. And we're going to talk about each of these in the next slides. But minimum loading means a generator cannot be operated below a minimum rating. Number 2 is reverse power. So this means that power cannot go backwards into the generator. So that's what the fuel save controller does. It protects the generator from reverse power flow. Number 4 is power management. That's really to do with the power quality and the active power and reactive power. And spinning reserve also. And I'll explain that in more detail, but it basically is a backup in case of high fluctuations on the load. But it also protects the grid. Power management, again, that's the reactive power and the active power. And the feed-in control, meaning if you're allowed to send power back to the national grid, it's the fuel save controller that will regulate this. And the performance, as we said, the main performance issue is to maximize the PV consumption and minimize the diesel consumption. So that is also the job of the fuel save controller. Okay, so minimum loading. This is because diesel generators are not built to operate below approximately 30% of their rated capacity. So whatever the rated capacity of the diesel generator is, it should not be run below 30% of that number. And the reason there is there on the bottom left. Those are some of the issues that will happen if you operate your diesel generator below the minimum rated capacity. You'll get soot in the cylinders, you'll get wet stacking of the soot deposits in the turbo, carbon deposits on the liner, piston, injector nozzles, you'll get high crankcase pressure, you'll get oil leakage in the manifold and the exhaust. So basically, it will shorten the life of your diesel generator. If you operate your diesel generator below the minimum rated load, it will cause damage and shorten the life and void your warranty of the diesel generator. So the fuel save controller maintains the minimum rated capacity of your diesel generators. So that's one function that it has. And the way it does that, you can see on the load profile on the bottom right, it has the minimum load on the diesel generator, and everything above that is from the solar energy. So now reverse power protection. This is another function of the fuel save controller. We do not want power from the solar energy to go backwards into the diesel generator. Now, most diesel generators have built-in protection for this, but it will just shut down. That is their protection that's built in. It will shut down the diesel generator, and then you have no power to your load. So what the fuel save controller does, it is able to curtail the production of the solar panels. It's able to reduce the production of the solar inverter, so that there's no power that goes back into the diesel generator, and you can continue to have power supply to your loads. Again, this is to protect your diesel generator from damage and also to prevent blackouts. The diesel generator will shut off if there's reverse power flow. And also the power quality. So it is the function of the fuel save controller to adjust the reactive power to make sure that the diesel generator operates in a stable operation window. So there you can see a graph of what we mean there. It should be between 0.8 and 1 of the power factor. That's the ratio of the reactive power to the active power. So it's the job of the fuel save controller to maintain this power quality in the optimal window. And this is to protect your diesel generator, but also to prevent grid penalties. Because if you're connected to the grid, there's always reactive power penalties. So the fuel save controller prevents this. And lastly, spinning reserve. So spinning reserve, it means that the diesel generator, this is a way to prevent frequent starting and stopping of the diesel generator, because we know that the load will vary very quickly. It will have peaks and valleys, and we don't want the diesel generator to be starting and stopping, and that will damage the diesel generator if it has to start, stop very quickly throughout the day. So spinning reserve allows the diesel generator to have the turbine spinning even though some of that power is not being consumed, and that is to account for the variability of your load. Again, this protects your diesel generator, and it ensures stable power supply to the load. And this is the function of the fuel save controller. And then also export limitation to the grid, because you can have this solar, diesel, and grid, a hybrid of all three power sources. So the fuel save controller will prevent export to the grid. So this is a very great function because you can have solar as your primary source of energy, you can have grid as your secondary source of energy, and you can have diesel as your backup supply only. And the fuel save controller will prioritize in this way, and it will also prevent power from going back into the grid. So in a summary of the concept, integrating photovoltaics into existing diesel system will enable reduction in fuel cost and will guarantee an efficient electricity supply. That's the basic of everything I've said, is that it will reduce your fuel costs, it will ensure the stable supply of your power, and it will protect your equipment. In fact, it will extend the life of your diesel generator. If you add solar to existing diesel generator, it will extend the life of your diesel generator. Okay, so now we're going to look at the product itself. So we work with a product called Encombi, the ECPV or the EQ. And today we're going to show you specifically the product combination. It's called the EC Cube, and inside the EC Cube is the ECPVX. And I'll explain all of this. But you can see the E Cube on the screen right there. So it comes as a box like this. And all of the connections are inside the box. And there's an optional screen on the front. It's a touch screen LCD display for local monitoring. It will give you all of the performance information right there on the screen. And it looks like this. So it's very easy to install and to fix somewhere near your power supply. It's a very neat and simple product. So this is what you see on the screen is called the E Cube, and inside is the ECPVX. Okay, so what is the ECPVX? It is a fuel safe controller. It's what we've talked about all day today. And it can manage up to 4 sources of energy. It can manage diesel generator. It can manage solar PV panels. It can manage a battery system, and it can manage the grid. So you can have all 4 or only 2 or 3 or whatever you like. This fuel safe controller will intelligently balance and monitor up to these 4 sources of energy. So basically there you see the ECPVX. It's a small device that goes inside the E-Cube box I've already shown you. And so when you purchase this, you get the software and the license, and you get this piece of hardware. And it comes inside of that metal box, the EC Cube. So what does it do? So when it's working with the grid, it can maintain a fixed power quality, the active and reactive power, and it can also maintain the importing from the grid and the exporting to the grid. And it can charge your batteries at a set rate if allowed. So you can set the parameters if you want to charge the batteries from the grid or not, and you can set the parameters to only charge if the batteries go below a certain threshold or something like that. There's endless parameters that you can set for your exact needs. And it also can work with the diesel generator and a battery. So it will maintain the load on the diesel generators. It will not go below the minimum rated load. And it can share the reactive load with the gensets to maintain your power quality. And it can use the diesel generator to charge your batteries. So that's really amazing because, as we've said, there's the minimum rated capacity of the diesel generators. They have to run at 30% or they should be off. They shouldn't run at 10% or 20% of their capacity. So if you have batteries and a diesel generator, that means when it's running at its minimum rated load, you get the maximum efficiency because this can at least be charging your batteries. Even if the solar energy is enough to supply the whole load, the diesel generator has to run at 30%. So you might as well save this energy in your batteries. So that's a very exciting development for the most efficient performance. And when it works with the solar, the ECPVX, so it acts as a voltage reference for the PV. So that means even if the grid fails, your grid-tied inverters can continue to produce. It maximizes the PV consumption because we know this is the free energy from the sun. So this is what you want to consume the most of, so it will maximize the load on the PV. It will also share the reactive load with the PV plant to maintain the power quality. And if you have batteries, it will, instead of reducing the PV output, it will charge the batteries with the PV. So it can do all of that. So yeah, this is what it can interface with the genset controllers, with the solar inverters, with the batteries, and also with power meters to regulate the power flow. So this is a line diagram of what it would look like in an off-grid scenario. In the bottom left is the diesel generator. So one fuel save controller can handle up to 16 generators, 16 generators. And it can manage up to 32 inverters from one fuel save controller up to 16 generators, up to 32 inverters. So the capacity is not in terms of the AC output, the capacity is limited by the number of devices. So you can have up to 32 inverters of any size and up to 16 diesel generators of any size. And this works very well with the Huawei inverters, and it works across a wide variety of genset controllers as well. So it's almost universal. So it's very easy to apply. And here's the same line diagram in an on-grid scenario. So it's exactly the same. It has the diesel, it has the solar, and it has the grid as well. And you can see there's a power meter, there's a genset controller. So we can share this all in detail. Everyone will get these slides in their email after this presentation. So you don't have to memorize all of this. It also comes with a cloud monitoring software. It's an optional additional cost, but we always recommend it. So you'll be able to see the performance remotely. You'll be able to log into the cloud, and it's available on any platform in any browser. And you'll be able to see all of the data, the performance data, the live data, the past data, if there's any alarms or anything like that. So you can see a lot of information on the cloud. It makes it very easy for monitoring the performance. So it's easy to set up, and it comes with a web interface as well, the EC Web. So it's easy commissioning, easy installing, and we can make sure that you have all of this information in advance. We can even do trainings with you how to install and how to set up everything, so you don't have any problems when you get to site. I mentioned earlier you can have a panel, an LCD screen on the box. So that means live in person, you can see, there's an image on the screen right there. You can see exactly what's happening right there on site. It will show you on the LCD screen display. And the data logging on the cloud. This is the portal. It will give you the historical data, visualization, analysis of the performance, and so you can get a plethora of information about how it's performing, and the historical data and all of that is available remotely. So here's just a few more line diagrams. This one is showing grid and solar and diesel generators. And so this is just an example of how it could be designed onto your projects. Here's another example, just a different scenario. Yeah, just letting you know that it's very flexible on a wide variety of systems and system designs. As I've said, it can go with the grid, the solar, the batteries, and the diesel generators. Okay, so that brings us to the end of this topic today. I hope you have understood the concept of the PV diesel hybrid solution, and I hope you have at least understood that we do have a solution for you. If you need more detail on the product or on anything, you can reach out to us and we can go over it in more detail. For all of our customers, we're happy to train you all on how to install everything in general. So today's presentation is just to familiarize yourself with the concept and with the application, and to give you confidence that we have the solution for you. If you need the products or if you need any assistance, feel free to send us an email or to reach out to us on LinkedIn or phone or anything like that, and we're happy to go into more detail. So now I'm going to go through the questions. So if you have any questions, this is a good time to type them in and mark them as a question, and I will be able to publish them, and we can go through one by one. Okay, so the first thing, will you share the presentation? Yes, you will receive these slides in your email automatically. If you're here, you've obviously registered with your email address, you will receive it. Okay, number 5, how to work. I think I've explained that. If you have something specific, please let me know. Have you done any working on the payback period? The payback period depends entirely on the application. It depends on how much diesel you're using on a daily, weekly, monthly, annual basis. So I know in some equipment you can give an estimate, but in the PV diesel solution, it entirely depends on how much diesel you're consuming and the time of day that you're consuming it, and also your price of diesel. The point is, if you're consuming a lot of diesel, the payback period is fantastic. It's that simple. If you're only consuming a little bit of diesel, the payback period is longer. But if you're spending a lot of money on diesel, the payback period is absolutely worth it. It can be 6 months or a year and a half. But if you're consuming a little bit of diesel, it could be 2 years or 2.5 years or more. It all depends on how much diesel you consume and the price of your diesel. Is the ECPVX compatible with all genset controllers? Almost all. I don't want to say all because there could be some out there, but very, very many. Chances are very, very high whatever genset controller you're thinking of is compatible. Almost all of them. I don't know of any that are not compatible. Okay, let me see if there's any questions on this side. Okay, let's see. Someone asked, can you please explain last 2 slides again? I don't know which. Okay, try to mark questions as a question, please. It will make it easier for me to go through these. Okay, so which one? So this guy said, can you please explain last 2 slides? I don't know which 2 slides you mean. What will be the savings in fuel consumptions percentage during the day? So this is highly dependent on your application. It will vary from site to site. It depends on how much fuel you're consuming. It depends on the time of the day that you're consuming it. And it also depends on your load profile, if you have big spikes or if it's very consistent. So I cannot answer this question because it varies from site to site. It can be up to 60%, 60 or even up to 70%, or it could be as little as 20%. So it really depends on the load profile and the specific application. Every application is different, but it can be up to 60 or 70%. Any existing project use same controller? Can you share the online monitoring for any existing project? This has been used in many, many projects. In speaking from Nairobi, Kenya, we have more than a dozen, almost 20 of these already installed. And I know around the world, there are so many more. Can you share the online monitoring for any existing project? No, I cannot. But I think if you go to Encombi.com, you may be able to find a demo site or something like that. I'll type it in the chat box, Encombi.com. Okay. Can you explain ratio of load capacity, DG, and solar system? So Okay, it depends on the load, it depends on the equipment, and it depends on the time of day. So we know that solar energy is a curve. Every day is a curve like this. The morning and the evening have low production, and the peak production is in the daytime around noon and 1 p.m. So that's the solar energy that's available. So it depends on your load. What does your load look like? Are you consuming in the morning? Are you consuming in the evening? Are you consuming in the middle of the day? Because that's your potential for consuming the solar energy. Now we have to consider the diesel generator at 30% minimum load. So we want to keep it at 30% or all the way off. So it really depends. It varies from load to load. Every load profile is different. Every application is different. It depends on what time of the day your customer is consuming diesel. And it depends on how much they consume, if it's stable or if it varies greatly. So every application is different. Can we connect ECPV with SCADA? Yes, you can. Will it be okay for 7 kilowatt motor for gold mills? Okay, I don't know gold mills. 7 kilowatt is quite small for this, and so um, you're not with a 7 kilowatt your PV, or what is it? It doesn't matter really. It's a small amount, and so the diesel you're consuming at this site cannot be very much, and so the payback period on such a small site will not be very good. It will be years to save up the money to control this. This is much better for 50 kilowatts and above. If 50 kVA diesel generator. If you have 50 kVA or above, now this is a very good product. Um, so on the very small products, very small systems, it won't be cost effective. What is the cost of the fuel save controller? So it depends on a lot of things. So there's different sizes, there's different options, but we are talking about $2,500 and up. $2,500 and up. So for the very small installations, it will take a long time to save the diesel to pay that up. But there's some people who consume $1,000 of diesel every month, and for them, this is an extremely exciting product. But if it's a very small site consuming very small amounts of diesel, the payback period will be very long. So we appreciate your attendance. Thank you very much for joining. We hope this was helpful and informative.